quantized single mode electric field. Let we consider this the expression of quantized single mode electric field, and where this thing, this E, this is equal to h cut omega b divided by epsilon r. So this is the value, and the relation between A and a dagger is equal to A is equal to x1 plus iota x2, and a dagger is equal to x1 minus x2, and you can find out x1 from these two equation and x2 as well, and if you want to add this and this expression, then this term and this term will be cancelled out, and you can get x1 which is equal to x1 which is equal to 1 over 2 and 2 a plus a dagger. And previously in a previous lecture we have written the value of x1 which is equal to this, and the value of x2 which is equal to 1 over 2 iota a minus a dagger. So this can be obtained from these two equations. And now in terms of x1 and x2, this electric field, this single mode electric field can be expressed in terms of x1 and x2, and this is very simple that for annihilation operator we can put this term, and for creation operator we can put this. So you can see here, and then further if exponential is taken in the cosine and sine omega t, then this exponential cosine omega t minus iota sine omega t plus x1 minus x2 cosine omega t plus iota sine omega t. So after some multiplication, because if we multiply this term with this term with this with this with this, and similarly if I multiply this with this with this with this, and this with this, then you can get these whole terms. And here one thing is clear, that there are something that terms that can be cancelled out, because minus iota x1 sine omega t, this term can be cancelled out with this positive term. And another thing is iota x2, this is positive and this is negative. And then we have x1 cosine omega t, one term is this and one is this. So we can add, this is a 2 sine, and 2 can be taken outside, and similarly the other term is x2 sine omega t, one is here and the other one is here, this also becomes 2. So from this we can take 2 common here, and x1 and this term x1 cosine omega t plus x2 sine omega t. And here the operators x1 and x2 are amplitudes of the two quadratures of the field with a phase difference, of pi divided by 2, because the phase difference of sine and cosine is pi divided by 2, because if you look, if we plot the sine theta, for example, if I plot this is sine function, then it means that the cosine function will be like this. So the difference between cosine and sine is pi divided by 2.